welcome to this audio record to this video. We want to talk about interprocess communication. So, in our previous lesson, we are able to learn about the why interprocess communication is important. And one of the reasons that we cited is that with interprocess communication will enable to help us to share information. So today we want to look at the mechanisms that are used for the processes to be able to communicate. And therefore, we have got two models that we're going to discuss in this case. We're going to discuss about the shared memory model, and then we'll also be able to discuss about the message passing model. So when we start with the first option, and that is the shared memory model. In this particular model is that a region of a memory is set aside for the cooperating processes to be able to communicate. So processes will be able to exchange information, that is reading and writing data, and this will be able to take place in a shared region. So shared memory region resides in the address space of the process that is creating it. So that particular segment that will be used by cooperating processes must reside in the address space of the process that is creating it. So there is one key caution that is being given when you're using the shared memory model. In this particular case is that with shared memory model requires that the cooperating processes to remove all the restrictions, that might be placed so that the process A does not access process B memories. So that restriction must be removed in order to ensure that that communication take place. And an example of this particular process or this particular model is what we call the producer-consumer problem. So in this particular case, that we have the producer process and the consumer process that want to run concurrently. They want to run at the same time. So why don't we have a buffer of items so that a producer process can fill that particular buffer with items, and then we have a consumer that can be able to empty that buffer items. So a buffer in this particular case basically is a region within the memory that is being shared by the producer and the consumer processes. So in this case, you can be able to see that concept of shared memory, or shared memory being demonstrated very well, whereby we have a buffer, which is a region within the memory that enables the producer and the consumer to be able to exchange information. Now, with the producer and the consumer, they must be synchronized. They must be synchronized so that the consumer does not try to consume an item that has not been produced yet. So synchronization will prevent the producer from producing more than is expected, or the consumer consuming whatever has not been produced yet. So in order for us to be able to keep uh, this buffer in check, there are two types of buffer that are being involved. In this case, we have the unbounded and the bounded. So with the unbounded is that in this particular case, there is no limit that is placed on the buffer. So the consumer can wait for a new item, but the producer keep on producing new items under unbounded buffer. But with the bounded buffer is that we have got some limitations whereby the consumer, if in case the consumer uh, must wait if the buffer is empty, and the producer must also wait when the buffer is full. So that's why we need that's why the bounded buffer that's how the bounded buffer works, because of the fixed size that is involved in this particular case. The consumer must wait until the buffer is empty, and the producer also must wait if the buffer is full. That is the that is how it operates. And here we have a picture that will be able to show that particular model. We have the producers this side, and then we have consumers on the other side, and here we have the buffer in between. So the producers keep on producing new items and placing them in the buffer, and then the consumer consumes whatever has been placed in the buffer. So in case it is empty, the consumer has to wait until that particular item has been made available. And if in case it is full, the producer has to wait until the space is made available for them to be able to produce more items. But the main issue that is being involved in this case, we have what we call concurrently. How does the producer and the consumer uh, be able to concurrently work together? Concurrently, in this particular case, if I want to read and at the same time the other one want to write and the same particular space, so how can we be able to solve that particular problem? That is the main issue that is affecting the shared memory model. And this particular issue is being solved by the second model, which we call the message passing model. So in the message passing model is that the communicating processes, they don't need to reside in the same computer. They can be able to reside in different computers, and then they are connected by a network. So process P and process Q can communicate to each other, send message and receive message, and this can only be made available by a communication link that exists between them. So there are various methods that can be used to create a communication link. We have what you call the direct or the indirect communication, or synchronous and asynchronous communication, and then we have got automatic or explicit buffering. Those are the three methods that are used whenever you want to create a communication link between the cooperating processes. Now, the first one involves naming. The first communication involves naming. In this particular case, that in the direct communication, each process that wants to communicate must explicitly name the recipient or the sender of that communication. So there is an explicit way to ensure that this message as its leaving point A is going to point B, and therefore this is the recipient and this is the sender, that this is the message. So there is an explicit way of naming each and every item or each and every component that is involved in this particular communication. And that's why uh, uh, there are some properties that must be there for this communication link to be able to work. So the first property that must be paid and must be available is that there must be only two processes that are involved. So in this particular case, it does not go beyond two processes. There must be two processes, not one or three, two processes that are involved. Then we have got the identity of the processes must be known prior to the communication. So there is no way it can be unknown to unknown. It must be known to known. So A must know that B exists and B must know that A exists. So there must be the last property in this particular case is that the, the, the communicating processes must establish only one link. There is no more than one link. There is only one link that must be established in this particular case. Then we have the second one, we call it indirect communication. In this particular case, the sender and the recipient processes create or they communicate by a mailbox. The message that I want to send to point B will go to the mailbox, and then point B will be able, or the process B will be able to access that message from the mailbox. So the process can communicate with other processes via different mailboxes, but two processes can only communicate if there exists a shared mailbox. So there must be a shared mailbox in order for the process A and process B to communicate, but it doesn't limit that process A cannot be able to communicate to process C. It can communicate to process C, but if and only if there is a shared mailbox between them. That is critical for us to understand in that particular case. And then we have got a diagram here that will be able to show us how this communication takes place. So we have process A and then we have process B. In this particular case, we can be able to see that in each and every message that is being sent by process A, there is an explicit naming of the mailbox that is involved. In this particular case, we have the mailbox M being explicitly named in this particular case, and then we have process B in this particular case, and this process B again in this particular case, it is explicitly naming the mailbox that is involved when retrieving the message. So that's how the direct communication takes place. Then we have got the second method that is being used, synchronous and asynchronous communication. In this particular case is that communication between processes only takes place through the two system calls, that is the send and the receive system calls, or the system, the primitives. So in this particular method is that there must be two system calls, that is the send and the receive system call. And these send and receive system calls, they exist in different status. We have the blocking send. So with the blocking send, in this particular case, that the sending process is blocked until the message is received by the receiving process or the mailbox. Then we have got the non-blocking send. So with non-blocking send is that the sending process sends the message and resumes the operation. So it keeps on sending, whether the message has been received or not, it keeps on sending. So then we have got the blocking receive. So the blocking receive in this particular case, the receiver blocks until the message is available. The receiver blocks until the message is available. Then we have the non-blocking receive. In this particular case, if the message is there or not, the message the message is valid or null, that is not important. In this particular case, it must retrieve a message. That is the non-blocking. Now, it is critical for you to understand in this case that when both send and receive primitives are blocking, either this one is blocking send and this one is blocking receive, there is a meeting, there endeavors between the sender and the receiver. So when we have those two states, whereby we have the send and the receive being in the blocking state, then we can be able to communicate. We can be able to communicate. The sender and the receiver can be able to communicate in this case. Lastly, we have the last method that is involved in this case. We have got called buffering, and we said we have got the automatic buffering, and then we have the explicit buffering. So in this case, that the message that is being exchanged must reside in a temporal queue. There must be a queue that is used. It is used to help to hold messages. So we have various methods that are used to implement this queue. One, we have what we call the zero capacity. A zero capacity buffering is that in this particular case, there is no any message that is in a waiting state that is placed in that particular queue. So the sender must block until the recipient receives the message. So a message must, if in case the sender send a message in this particular case, that message must be received first before you can be able to send another one. So there is no message that must be in a waiting state. That's what it means by zero capacity. And then we have the bounded capacity. In this particular case, there is a finite number of messages that can reside in this particular queue. And if this queue is full, a new message, the message is, in case the queue is not full, a message is placed. But if in case it is full, a message is blocked until the space is made available. And in case if this is empty, the message cannot be retrieved, but it is full, the message can be able to be retrieved on the other end. Then we have the unbounded capacity, and in this particular queue is that there is no finite number of messages that must be held. In this case is that the number there is any number of messages that can be in a waiting state, in this case waiting for the recipients to come and retrieve them. But the sender keeps on producing new messages. The sender keeps on producing new messages. So the message can be kept there until when the recipients will be able to come and collect them. But it keeps on producing more. So that is all about the interprocess communication models. And thank you for listening. See you next time.